What's happening, you guys? Welcome. My name is Anoop. This year is Vedantu 9th and 10th English channel. Thank you for stopping by. Today, we're going to be doing the fourth session of Human Eye in Colourful World. And the concept that I'm going to teach you today is going to be one of the most interesting concepts that you have in physics. What are we going to look into today's session? We're going to understand about atmospheric refraction and what are the applications of this particular concept. It's super duper interesting. So stay till the end and enjoy the rest of the video. So that's it, guys. Let's get into today's session. So this is the code for today with a small sense of positive vibe. Let's start. The code for today is this, guys. You can never cross the ocean until you have the courage to lose the sight of the shore. Now, everyone is tethered, or everyone has this. We all have this this sense of not taking risk, because we are all scared of what's gonna come, what might happen next. But trust me, guys, you guys are in that stage right now. You're in 10th standard, moving on to 11th and 12th. Once your board exams are done, this is the time that you start taking risk. This is the time that you explore yourself. This is the time you understand what are you good at, what are you bad at. So forget about the shore, start taking risks, and trust me, guys, you would actually feel good once you explore the options that you have around you. Because trust me, the 99% of the population who's watching this video right now have probably two things in their mind: engineering and doctor. I'm pretty sure that the ones who are watching the video right now will be like going like this. I know. Even I was in that category. But there are a lot of other options out there, people. Explore your options, see what's the best fit for you, and this is your chance to do that. Now, not right now, because the next 3 months, focus on your exams. After your board exams are done, you have still about 2 to 3 months before you make that choice. So use that wisely to see what you're good at. All right. I hope that you guys take this advice. It's something I wish someone had told me back that time. At least no one was there to tell me this, but I'm telling you this. Take risks, because those risks will yield you something good. Alright, so that's it, guys. Let's get into today's session. So we have already completed 3 sessions, that is refraction through a prism, dispersion through a prism, TIR, that is total internal reflection, and rainbow formation. Today we'll be looking into atmospheric refraction as well. And in the next session, that is we'll be doing scattering of light, and by that we will have completed Colourful World as well. So that's it, guys. Let's get into today's session. So in the last session, this was the homework, by the way. What is the angle of refraction? Sorry, when the angle of refraction is 90 degrees, what is the angle of incidence called as? And the answer, you guys know this, people. It's nothing but the critical angle. And if you go overboard, if you go greater than the critical angle, then what you get is something called as total internal reflection. Right? So that is the answer. With that said, let's get into today's session, guys. Pens down, listen carefully. Okay, one of the most beautiful things in life that we can enjoy is the night sky. Completely free. Just go to an open terrace and you can just look at that beautiful sky out there, the celestial bodies, stars and planets and everything. But have you ever taken a minute and wondered, why do stars twinkle? Like, is it because of the poem Twinkle Twinkle Little Star? Is that why they twinkle? Nah. Also, there's this misconception that the position of the star that you see is the actual position of the star. For example, you see the star over here, and this is where the star is. But the fact is, people, even though you see that the star is over there, the star is not actually there. The star would be somewhere over here, but it appears as though the star is over there. Why is that? So that one statement would have broken down your belief system. You'll be like, sir, my whole life was a lie. Yes, we understand. That's how we felt it. Now, the position of the stars, the position of the planets, the position of the sun, none of them are where they are appearing to be. It's actually different. Why is that? What could be the possible reason to explain these phenomena? That is what we're going to talk about. So I hope I have everyone's attention now. Now, people, let's understand about atmospheric refraction. Let's say there's a star. a distant star somewhere out there in the Milky Way galaxy, and the light is coming and falling onto the Earth's atmosphere. Now we know that our Earth's atmosphere is of different layers. You know that troposphere, stratosphere, you have to your exosphere, ionosphere, so many spheres are there. Now all of these different layers of atmosphere have different densities. As you guys already know, as you come closer and closer to the Earth, the air becomes denser and denser. As you go higher and higher, the density of the air actually decreases. So as the light is traveling from vacuum, which is nothing but space, space is purely vacuum, there's nothing, there's no air, there's no water, there's no solid, nothing. So as that ray of light is traveling from vacuum into the atmosphere, which is made up of gas, don't you think the ray of light would refract? Because it's going from a rarer medium into a denser medium? Absolutely. And if it does happen, would it move towards the normal or away from the normal? When it's going from a rarer medium into a denser medium, does it go towards the normal or away from the normal? You guys know the answer for that. It will go towards the normal. So what would happen? The ray of light, if this is the normal, if I were to draw a normal somewhere over here, the ray of light would basically go like this. Now, the actual path of the light was supposed to be this way. It was supposed to go straight. It was supposed to go straight ahead. But then because of refraction, the ray of light takes a slight deviation and moves towards that. And as that ray of light is passing through those different layers, what happens? It gets refracted further and further and further away. And finally, people, what tends to happen is that you see that the ray of light would somewhere basically, I think I'll be able to show that GIF over here. Okay, it's not there. Okay, anyways, so so yeah guys, as it bends away and away, as it bends towards the normal, what happens is that instead of the ray of light which was actually supposed to go this way, what tends to happen is that the ray of light would look something like this. Now, if you are standing over here, or if you are looking at the night sky, according to your eyes, what would you do? You would start to trace back this wherever the ray of light is, because you know that your eyes, you cannot trust your eyes. So what would you do? You would start to trace back the step, and you see that the star is somewhere over here. But is that where the star actually is? No, the star is actually over here. But for us, it appears as though the object is over there, or the star is over there. So it's the same case with the coin wala experiment. You'd have probably done it, or the pencil wala experiment, or the coin is one of the best examples. So you put the coin inside the cup and you're not able to see the coin, but then when you start putting the water, you're able to see the coin magically. Why? Because it appears as though it's raised. So you have the original position or the actual position of the star, and then you have the apparent position of the star. Now because of this shift, what we actually see is not the object, but we in fact see the image. It could be a star, it could be a planet, it could be even the sun. We are actually seeing the image and not the actual object. And like I told you guys, as we go closer and closer to the Earth's surface, the density of the air increases because of gravity. Obviously, the density of the air increases, and the refractive index also changes. So the refraction would also happens in a different way, right? So this is how, guys, what happens is that the ray of one single ray of light basically undergoes multiple refraction before it reaches our eyes. And when we undergo that refraction, it appears as though what? It appears as though the ray of light is actually coming from there. And this is what is called as atmospheric refraction. So if you are asked to define what is atmospheric refraction, the deviation of the ray of light because of the Earth's atmosphere, as the Earth's the density of air is different in the atmosphere, or in other words you can say that as the refractive index of the atmosphere is changing every now and then, that is what is called as atmospheric refraction. Deviation of the ray of light because of the changing atmospheric changing refractive index, that is what is called as atmospheric refraction. That's all, simple. If you've understood this one concept, guys, you can understand that the position of the star or the position of a planet is never where it seems to be. So there's a height difference that is happening because of this refraction. Alright, so now I think you guys are able to understand that your whole life was a lie, right? You understand that why this happens. Now, there's one more phenomena that happens pretty much the exact same way, which is called as the early sunrise and early sunset. I don't know if you guys know about this. You are actually able to see the sun 2 minutes before the actual sunrise, and you're able to see the sun 2 minutes after the sunset as well. Have you ever wondered about this? I don't think any of you would have thought about it until CBSE had put this in your syllabus. But this is a fact, guys. Now, why does this happen? Again, it's the exact same thing. You see this? This is the actual position of the sun. But because the ray of light is coming from the vacuum into air, again, as it is traveling from a rarer medium into a denser medium, it undergoes refraction and it appears as though so what happens, the basically after refraction will reach your eyes, and for your eyes, because the ray of light is coming like that, what will happen is that it will try to trace back the step and it will appear as though the sun is over here. But is the sun actually there? No, this is the real position of the sun, but this is the apparent position of the sun. So there is a shift that is happening. This is why, guys, we are able to see the sun at least 2 minutes before the sunrise. The same goes with when you're talking about sunset also. So there's a real position. Again, the ray of light is coming through the vacuum into the atmosphere, and as it is doing so, it undergoes refraction and then it appears as though it's a little raised up. So you are able to see the sun. You see this? This is the real position of the sun, and this here is the apparent position of the sun. You are able to see the sun even after the sunset. The sun is long gone. So this is your horizon. This is where you can see. This is where basically the sky and the land meets. That is the horizon. Now you can only see till there. You cannot see beyond the horizon. But because of atmospheric refraction, it appears as though you can see beyond the horizon. In fact, you are able to see the sun 2 minutes even after sunset. Right, guys? Such beautiful, I don't know, whoever created this, trust me, guys, whoever created the world, it's the way that they've done it is just beautiful, because all these things are not things that would have happened on its own. I don't know, but yeah, the Big Bang Theory, all thanks to the Big Bang Theory, I would believe. But yes, again, all of these are just beautiful phenomena that explains how the universe around us works. In fact, if you talk about the black hole also, it's even more beautiful, but yes, we'll talk about that another day. You can see this ray of light bending because of gravity over there. We'll talk about that later. Nonetheless, alright, so I hope you guys understood this, people. Now, let's understand an interesting question. Why do stars twinkle? Twinkle, twinkle, little star. Why do you twinkle, little star? Let's understand that. Alright, now, here's the thing, guys. Twinkling is nothing but the changing of the intensity of light. The changing of intensity of light. For example, if I, alright, I'll just give you a simple example. For example, if I turn on the light on this flashlight, if I turn on the flashlight, now, if I keep it right in front of the camera, the intensity is maximum. But let's say if I turn it off and turn it back on, what's happening right now? If I turn it back on, turn it back off again and again and again, what's happening is that the intensity of light is changing. Suddenly it's 100%, then it suddenly drops down to 0 when I turn it off. And then again goes back to 100, again 0. So this switching between the intensity of light, this is what is called as twinkling. This intensity, the switch between the intensity, that is what is called as twinkling. Now, here's the thing is, we all know that the earth is constantly rotating about its axis. So if the earth is rotating, don't you think the atmosphere is also rotating along with it? Absolutely yes. Atmosphere is also rotating and the earth is also rotating. So imagine this, guys. Imagine this. Imagine that there are air particles over here. You see this? Look at this GIF carefully, guys. You see this? Suddenly you see that there is air particles. Sometimes the density is very high. Sometimes there are more number of air particles in one place. Sometimes it's less. So the density of the air is constantly changing because of the rotation of the earth and because of the movement of the air particles. So if the density of the air is constantly changing, don't you think the refractive index of the air also is constantly changing? Obviously yes. So when it's denser, the refractive index is more. When the air is less denser, the refractive index is less. So there is a constant change in the refractive index happening because of the rotation of the earth and because of the movement of the air particles that is there. And this is the reason why stars twinkle. Why so? Think about it, guys. Every single second as we speak, the air particles are rotating. the air is not constant, no, because there's always a high pressure low pressure created and the air is constantly flowing, so the atmosphere is constantly changing and the earth is also rotating. So yes, everything is changing every single second. So what happens is that if there's a person standing and looking at the star at one point of time, let's say at at one point of time, let's say you're looking at the sky at like every 1 second you're checking. So let's say that you started at 12 a.m. You started at 12, yeah, you started at 12 a.m. You started late in the night. You want to see what is the star like. And at 12 a.m. you see that the intensity of light, all that 100, see there are 3 rays of light coming and falling now. Let's say that all the 100% of light is coming and falling into your eyes. That is, all the 3 rays of light are coming and falling into your eyes. Again, after undergoing atmospheric refraction, it is coming and falling into your eyes. So this time what happens, you see the sunlight, you see that the star is really, really bright. But after 1 second, that is at 12:01, you see that the amount of light that is falling into your eyes is 80%. Let's say that only 2 rays of light is falling into your eyes and 1 ray of light is coming your way. Again, why? Because the rays of light are constantly undergoing refraction and the amount of refractive action is constantly changing. Sometimes it gets refracted more, sometimes it gets refracted less. Why? Because the density of the air is constantly changing. Let's say that at 12:02 again you see that the what to say, the intensity of light goes back to 100%. Again goes back to 80, again goes back to 100, again goes down to 40, maybe even 20. So this switch is constantly happening. And this constant switch is the reason why, guys, we see that the star appears as though it's twinkling. But is the stars actually twinkling? No. It's like the sun. Sun is like a star is nothing but a sun. Or in other words, our sun is nothing but a star. It's not the other way around. Our sun is nothing but a star. So is it blinking? Is it twinkling? No. Just like that, even the stars are constantly giving out light rays. But because of refraction, because of this constant change in the density, only a part of light sometimes reaches, sometimes the entire light reaches. Exactly like this. Again, the same old example, like I told you, you have to see that it keeps on, the intensity of light is constantly changing, and see what happens. It starts to twinkle, and this is what, my friends, is what is called as twinkling of light, because the intensity of the light that is reaching us is constantly changing. Is the stars actually twinkling? No, it is not. Star is continuously burning, just like the sun. The star is also continuously burning, but the amount of light that is reaching us is changing every single second. So sometimes more amount of light is falling into our eyes, so you see that the star is bright. Sometimes less amount of light is falling into our eyes, so the brightness of the star appears to be less. That's all. This is the reason. But on the other hand, if you talk about planets, guys, planets do not twinkle. The reason why planets do not twinkle is, guys, because planets are very close by. Planets are close by, so the rays of, because if you look at a planet, there are many collection points. You see this, there are several light, because of the sun's light falling on it, several rays of light are coming towards us, and because of this, because of the collection of points, because a star is really, really far away, so it looks like a point source. Whereas a planet, on the other hand, has a collection of points, and because of that, this won't matter much. The refraction won't matter much. So basically, what would happen is that it appears as though it's in the, it's not, twinkling at all, because the intensity of light would be pretty much the same. Because again, there are several light rays coming and falling in, light rays are falling into your eyes, so it does not really matter. But in the case of a star, which is very, very far away, again, hundreds and millions of kilometers away, or light years away, several light years away, those are very, very far away, and because of that, they are point source. Whereas planets, on the other hand, are closer, and so you don't see planets twinkle. And that's how you differentiate between a star and that of a planet. Alright, so I hope I did not bore you people. I hope you guys were able to understand the concept. I know towards the end, yeah, I know, yes, but I understand people. But then again, these are, again, if you ask me, as a person who studied about a little bit of this thing and all that, like who likes talking about space and stuff, these concepts are very, very interesting. And if you're someone who likes to learn about space and all that, I'm pretty sure that you would find this very, very interesting, because these concepts explains why things happen, not just how it happens, but why does it happen. So yes, I hope you enjoyed it, people. If you want more such amazing sessions and want to gain 100% knowledge and 100% mark as well, the link is given in the description below and the pinned comment section. So once you click on that link, people, it's going to open an array of beautiful opportunity for you guys to study with the best of the best teacher, in the best of the best online platform. You are going to get the chance to attend unlimited live classes. How many ever live classes you want, with the highest level of quizzes in every single session, with the leaderboards and everything. And the best part, guys, you get to compete with the rest of the world and check what you're good at or where do you really stand. You have that opportunity, the power in your hands, in your palm, the power of the entire world, if you ask me, in the palm. That is how good, that is the opportunities that you have. And other than that, guys, even if you miss out a session because you have unlimited classes going on, you would obviously miss out a couple of sessions. But don't worry, guys, you can still take part in the quiz, still see the leaderboard and see where you would have been if in case you had taken part of the class. And apart from that, you can download all the premium content of every single session and the handwritten notes, so you may never miss out on anything that is important. You are always going to be one step ahead, because nothing is ever going to leave your sight. You can download the sessions, you can watch the recording how many ever number of times you have. With all of that, inside the class, you will not just have one teacher, you will have two teachers. You'll have the master teacher and the class teacher to help you solve each and every doubt. And apart from that, unlimited tests and assignments as well to check where you're really going wrong. And based on these tests and assignments, you also get a detailed report card as well. With all of these, you have 5,000 plus micro courses. Imagine that, guys, 5,000 plus micro courses and crash courses, all for free for that one, the price of that one single, one single pro subscription course. Again, the link is given in the description as well as in the pinned comment section below. And the coupon code to avail the discounts is AME Pro. This is my coupon code, AME Pro. So once you enter this coupon code, what would you get is basically a discount of about 500 rupees if you go for the 1 month subscription. So the price comes down to 2,159. And if you go for the 3 month subscription, you get a discount of about 1,300 or 1,400, and the price comes down to 5,599 rupees. So all of this, people, for such a cheap price. Now think about it. Even in that 2,000 rupees, you would have roughly attended about 200 sessions in that 1 month. And that's the minimum number of sessions. You can go up to 300, 400, 500, totally up to you guys. It's totally up to you guys. Even if you do a minimum of 200 sessions, you would have roughly paid about 11 rupees per session. Just 11 rupees. And if you go for the 3 month subscription, it's going to be even lesser, bring down the price down to be 9 rupees per session. 9 rupees per session for your own future. You know that in the next 3 months you're going to be appearing in your board exams. If you want to revise, you want to restudy everything. For all of that, link description, click coupon code AME Pro. Alright, the price of it, guys, trust me, is less than what you pay for lace. Trust, every single day you at least spend at least 200, 300 rupees. But this is for your own future, which will be less than 11 rupees per session. Right, guys? So that is it, people. That is all I had to teach. Now let's get into some questions and try to solve those questions as well. Try to give your best abilities, give your best shot in solving these questions, because these are the practice questions that is going to help you do better in your exams as well. So here's the first question, people. Refraction of light by the Earth's atmosphere due to the variation in air's density is called as what? What is the refraction of light by the Earth's atmosphere due to the variation in air's density is called as atmospheric refraction, reflection, refraction, dispersion, or both refraction and dispersion? And the answer, guys, is option number B, obviously, no doubt about it. Atmospheric, because of the air's density, the amount of refraction changes, or basically the light ray bends. That is what is called as atmospheric refraction. Simple. Second question: the time delay in the apparent sunrise and the it's not sun. What is this? The sun sire. Okay, sunrise. Yeah, people. Sunrise and the actual sunrise is what? 20 minutes, 2 minutes, 2 seconds, and 2 hours. The right answer, people. You guys already know about it. It is still what? 2 minutes. That is the apparent sunrise and apparent sunset as well. That is, there's a difference that is happening, the time difference. That is what we just talked about. Third question: all celestial bodies appear dash when they are because of atmospheric refraction. All celestial bodies appear higher, lower, at the same position, or none of these. We've already seen that, people. What do you think? That is the first concept that I taught you guys. The answer is going to be higher. It appears as though it is higher, but then the actual position is completely different. The apparent position. So what you see is basically an image, not the actual object. What you see is basically an image. Here's another one. Planets don't twinkle because planets are a collection of points. The twinkling of each point of the planet averages out. Planets are close, so not considered as a point source, or all of the above. What do you guys think? I'm pretty sure that a lot of you guys would have gone with the option of the first option, but the answer, guys, is actually all of these. All of these are the right answer, because yes, planets are a collection of points, and yes, like I told you, they'll just average out, because even if there's twinkling happening, because there is a lot of collection points happening, it'll just it'll just cancel out, so you don't see it as twinkling at all. And yes, planets are close by, so the ray of light would reach us faster, because the ray of light would reach us faster. So yes, planets don't twinkle because of all these reasons. Alright, so that is the answer, guys. Moving on to your homework question. This is your homework question. The air layer of atmosphere whose temperature is less than the hot layer behaves as optically dash medium. Interesting question. The air layer of atmosphere whose temperature is less than the hot layer behaves as a optically dash medium, denser or rarer. Let me know that the answer in the comment section below. Again, thank you for joining, people. I hope you guys were able to learn something new today. And if you want to enroll into the NTSC courses, people, these are the links. You can take a look at the link as well. You have 90% discounts going on right now, and the course will go until 13th of December, so you can take part in that as well. And again, the link is given in the description to enroll into the pro subscription course, and the coupon code is AMEPRO. Do not forget to like, share, and subscribe, people. Yeah, it's been a long time since I've told that. Do not forget to like, share, and subscribe. Hit that red button and also the bell icon as well. Thank you for joining. I'll catch you guys on the next one. Peace out, people. Have a great evening. Bye bye. Take care, guys.